This section of your textbook really extends on the last section of forming ionic compounds. It digs in a little deeper and helps you come up with the ionic formulas more quickly and with a little more confidence. And then it also teaches you how to name ionic compounds. So in the last video, we looked at this reaction, and we basically said, what's the formula for the compound formed? And didn't give you too much more than just, hey, count the number of Ks, count the number of chlorines, and that's our formula, KCl. Or here, there's 2 potassiums and 1 oxygen, therefore it's K2O. And here, there's 3 magnesiums and 2 nitrogens. And I tried to explain a little bit as to why that was, but in the end, that's pretty much all we did, was Mg3N2. It takes a long time if you're going to trial and error and figure out, all right, do I need 3 magnesiums, 4, 5? That would take a little bit too long. So this book uses this method, which I really like, and I've been using it for years, of how can we go directly from what is the charge of the 2 ions involved to the full ionic formula without writing out those Lewis structures. So in this case, if you've got calcium and it's combined with chlorine, what you do is the charge of the calcium turns into the subscript for the chlorine and vice versa. The charge for the chlorine becomes the subscript for the calcium. So for this compound, it turns into CaCl2 because the 2 plus turns into a 2 for the chlorine and the 1 for the chlorine turns into the subscript for the calcium. It's just that easy. Swap it. The important thing is you're not left with any pluses or minuses in the final formula. That's the number one error I see students do. You've swapped them. You've gotten rid of your charge by making it a neutral compound. The individual ions are charged because they either gained or lost an electron, but now they're canceling each other out because they managed to switch out and swap their electrons. So let's give it a try. Would this work on the ionic compounds we just examined? Let's look. If this +1 comes down here and the negative comes here, it's a 1 and 1. 1 and 1, which we've done. What about here? K plus O2. So the 2 becomes a subscript on the K and the 1 becomes a subscript on the oxygen. That's correct. What about here? Magnesium has a 2, nitrogen has a 3. So that means that the 3 comes to the subscript of the magnesium, the 2 becomes the subscript of the nitrogen, making an Mg3N2. It works every time. So what I want us to do is I want you to try it. Try and write out the ionic formulas for each of these compounds. So just as for this first one, we see that the aluminum and the oxygen swap charges. But the first step before you do it, so go ahead and pull out your periodic table and practice this. You have to figure out what is the charge on each of these, meaning where is aluminum? So for instance, aluminum is in group 3, so it forms a 3 plus, whereas oxygen is in group 6, so it forms a 2 negative. You need to be able to look at your periodic table and be able to tell these things. Or strontium, it's in group 2, so it gets a 2 plus, whereas chlorine's in family 7, so it gets a -1. Try to figure out first all of the charges on your paper before we create the compounds. Alright, so the only one that looked funny was this Fe3. So you might say, why did I tell you that? Well, iron can form either a 2 plus ion or a 3 plus ion, so I had to write it out for you. So I said Fe3 in Roman numerals designates that that's Fe3 plus. So check your work and see if you have labeled all of these properly. And if you have, then we can go to the next step of writing each of these and turning them into ionic compounds. So just swap the charges. Swap them. Make a big X on each of them. So if you ever hear me say, swap those charges, that's what I'm meaning. So each of these compounds becomes what you see over here. Al2O3. Strontium becomes Sr1Cl2, K2S, Mg2P3, Ca2O2. But then I took this one a step further. If ever you have the subscripts can be reduced, whereas in this case, if you divide both of them by 2, you become 1 and 1, you're supposed to reduce them. So calcium oxide's formula is not Ca2O2, which is what you would get from swapping the charges. It's CaO. And why that is because calcium has 2 electrons to give and oxygen needs 2. So they can react 1 to 1. They don't actually need 2 of each to react. So you always reduce. Whereas here with this Mg2P3, 3 is not divisible by 2, so you can't reduce. All right, and then for the last one, iron 2 oxide, it becomes Fe, or iron 3 oxide, Fe2O3. All right, so now let's go into naming. We figured out what the compounds are, but now we just need to name them. So naming is pretty simplistic. You just simply state the first cation, then you state the anion, but you change the ending of the anion to have an IDE at the end. So this first one, aluminum and oxygen, replace igen with ide to become aluminum oxide. SrCl2, strontium chloride. Give these next 4 a try on your own. See if you can't do it. Pause the video and then check yourself. Potassium sulfide, magnesium phosphide, calcium oxide, and iron 3 oxide. This last one's the one that's different. Because iron can have more than one charge, you place the charge. So notice it was iron 3. Even though there's 2 of them, it's not iron 2. The 3 correlates to what the charge was. Remember, it used to be Fe3+. So therefore, whatever that subscript is here on the oxygen, that is what becomes your Roman numeral inside of your parentheses. If ever your metal has more than one charge, then you have to do that. Now remember, we're going to go soon into covalent compounds. Ionic compounds are a metal and a nonmetal. Every single one of these has a metal, aluminum, and a nonmetal, oxygen. That is what makes them an ionic compound. So get really good at understanding ionic compounds before you go further. Alright, so now read section 4.6 and 4.7 in your textbook.